So this is going to be a basic PIM gear setup and the calibration of the unit. As we talked about in the sweep gear video, this is our sweep load, and now this is our PIM load. And as you can see, there's quite a difference between the two. Like I said, the sweep gear only puts out 1 watt of power, and the PIM gear will put out 43 watts of power, I believe. So the most important thing, just remember that we always make sure when we have this, we always just say we have the sweep load on or the PIM load on. The PIM gear will fry the PIM load, and again, those are very expensive. So in addition to the PIM load, we have the PIM standard here, and this basically creates a PIM, and it will help us do our distance to PIM and calibration. On the front of it here, it's kind of hard to see, there's numbers, and it says neg 80 dBm, and that's basically creating 80 dBm of a PIM to help calibrate and do our distance to PIM. So on our PIM load, we have our DIN female connector here, and then we have our DIN female connector here, and on the other end we have our DIN male connector here. So PIM gear is, for file savings, very similar to the other one. Again, to create a file, go shift file, already pulled up here, we'll go save measurement. Right now we already are in internal memory training, but if I want to change that, we'll go change save location. I can go up here and create a folder. So right now I'm internal memory, or sorry, location, internal memory, and we can do training 2. Enter. And we can scroll down and set our location. And to verify again, we are location internal memory / folder training 2. So with the PIM gear and sweep gear, they're both temperature sensitive for their calibration. Down here on the lower left hand side, last time I calibrated was 16.3 degrees Celsius, and now we're at 17.0. To calibrate, our DIN female port is up here. We will connect our PIM standard to the top here. And again, with all the PIM gear connections and anything finalized, we need to blow out connectors with canned air. And as I'm tightening this down with my hand, I want to spin that nut down and keep the other half of the standard still, because when we spin the whole thing, the center connector on the other side will spin and wear down and give us issues in the future. So once that's hand tight, pull out our connections again. We'll put our PIM load on top, and I'm actually getting a little ahead of myself. But we'll torque down our PIM standard, and to torque the PIM load onto the standard, we hold the square portion here and torque down that. If you don't hold that square portion, usually you'll end up over torquing it, which will give us issues also in the long run. So we have our PIM standard in line with our PIM load, and it'll actually tell us all this. When we go to calibration, we'll go shift cal, which is number 2. Start calibration, which is up here on the top right, and it will give us directions on how to calibrate the unit. So right here it says, to calibrate, connect PIM standard to test port, connect low PIM termination, which is the PIM load, onto the PIM standard, and we will hit enter. And right now it's calibrating 0 feet to the port at the top of the unit. Same thing with the sweep gear, except the sweep gear is calibrated to the phase cable. Here we just do the top of the unit. So once that first portion is done, it says remove PIM standard and low PIM termination from the test port. Reconnect only the low PIM termination to test port. Press enter to calibrate or exit to escape. So again, up here, loosen my standard, hold the square portion of the standard, and untorque my PIM load. Retorque our PIM load. So, again, now we have our PIM load on top of our test unit. We'll hit enter. And this usually takes a couple minutes to do, or a minute or so. And same thing with the distance default on the sweep gear, where you can change your cable. That goes for PIM gear also. We can change our cable. Right now we're on AVA 7, which is 1 5/8 coax. And I'll show you how to set that up in a second here, as soon as it's done. And along with that PIM standard, we can use that to verify that our calibration is good and our unit is measuring correctly. Since we know that's a known source, it's known to be, or it is set at neg 80 dBm. So once we go all green, our soft keys come back up here. We can go down to measurement, down here on the soft key, or you can go shift 4, and that'll also pull up measurements. Right now, we're set on PIM versus time, and we're set at 120 seconds. To change our time, we can go to test duration. It'll pull up over here our test duration. Same thing with the sweep gear. As the sweep gear, we'll select that. We'll have our test duration up here. We'll go change it to 30 seconds and then select enter. And now we're at 30 seconds. So when I run this measurement, go back to measurements, test on. We're set in dBc right now. So we're reading at a neg 180, 175 dBc, which is very good, which is what we should be looking for when the unit is calibrated, is neg 80s, neg 70s. It's okay to bounce around a little bit like that. You notice down here RF is on. Your test is on up here to show you the RF is on. And then up here we have our green light that is on, and you can also do emergency stop, and that'll turn off RF, and also emergency shut down was pressed. Well, up here. To change our limit, right now our limit is at neg 130 dBc. And that's AT&T standard for anything inline, so a diplexer, TTA, duplexer, anything like that puts us at neg 130 dBc. I think Verizon, regardless, is neg 140 dBc. So just like sweep gear, lower the better, further away from 0 the better. So a neg 170 dBc is better than a neg 140 dBc. To change our limit, we'll go shift limit over here on the soft keys. Right now, our amplitude, our limit is set at neg 130. We can change that to 140, and you don't have to worry about the negatives. It already does that. So now it dropped our line down to neg 140. You can do pass indicator on off. You can do a limit alarm to let you know when you're over that limit. And again, down right here, calibration is on, and it gives us our temperatures that we were calibrated at. So to check and make sure that our unit is functioning, and that's the other really important thing, we always have to have the PIM load or it hooked up to a system, being an antenna. Termination is an antenna. You can't just run the PIM gear without anything on it. It'll put RF out in the air, and you can burn yourself pretty badly with it. I know a couple guys have accidentally burned themselves with it before, including myself. But to double check, we'll put our PIM standard on top. Again, right here, it's kind of hard to see, neg 80 dBm. Torque that down. So it's basically going back to the first setup for calibration. Put everything together, PIM standard in line with the PIM load on end of it for termination. Now, since we're in line here with that PIM standard, we should be reading about neg 80 dBm. So again, here's our DBC, there's our dBm. We'll go measurements, test on, and we're at neg 80.8. So we're only 0.8 dB off of what that standard says. So that's very, very close. And even though it's failing, and don't get me wrong, we're neg 123 dBc, neg 80 dBm, that'd be failing to AT&T and Verizon standards and most standards, but it just shows that our unit is measuring properly. We know our PIM standard is measured at neg 80 dBm, and our unit is reading neg 80 dBm. So after 30 seconds, it automatically turns off, and we can hook up our PIM jumper to make sure that our jumper is good. The jumpers are the most finicky things. We have a lot of Superflex jumpers floating around. There's 2 Enritsu PIM jumpers that always seem to work out very, very well for us. But the Superflex jumpers with the JMA connectors on the ends, they tend to wear out after a couple months of everyday use. So over here we have our PIM jumper, and we have on either end a DIN male connector. So we'll take that, blow it out again, hook that up to the top of our unit. So we have our PIM jumper hooked up to our unit, and over here we have our end, and you can run coax all the way straight to it if you were doing like an RRH testing, something like that, but normally there's not enough slack in your coax. So we'll put our PIM load on the end here, verify our PIM jumper is good. It seems like kind of redundant to do this every time you break out the PIM gear, but especially when you're troubleshooting stuff or final testing stuff, you can chase your tail if you don't check yourself. If you don't put the PIM load on top of the unit, make sure the unit's good. If you don't put the PIM standard on there, make sure that's reading correctly to neg 80 dBm, plus or minus 1 or 2 dB is okay. Then attaching your PIM jumper, which we have on here now, and putting the PIM load on there and making sure that's okay. Because if it's not testing good up until this point, the rest of the system isn't going to test good. So we'll go over here, go measurements, and we'll go test on. And right now our PIM jumper is reading at neg 173, neg 180 dBc. And again, that's very good. The Enritsus have a distance to PIM also, which is like the distance default for the sweep gear. So when our return loss is failing, or our PIM is failing, we can use our distance to PIM and know about where it's failing. This one's a little more finicky than the sweep gear distance default return loss, but it works out very well still. So to get to that, we can go distance to PIM, and I'll pull up a graph with our 0 mark being our unit, and that's the difference between the sweep gear and the PIM gear. Sweep gear is calibrated to the end of your phase cable, where the PIM gear is calibrated to here. So your distance to PIM accounts for this 6 foot or 8 foot or 10 foot, whatever jumper you have. So you got to keep that in mind when you're doing your distances. Right now we're set at AVA 7-5, which is 1 5/8 coax. And again, to change that, we can go cable, and it should. There we go. We can go over here to our cable, and we can select all of our different types of cables. So again, whatever your main line is, that's what you want to set it at. So at this site I'm currently at, it's 7/8 main line. So even though there's 1/2 inch jumpers involved, the majority of it is 7/8 coax. So we're set 7/8 coax, and our distance is stop distance is 400 feet. I'm gonna change that. Go down here to the bottom here where it says distance, and we can change our stop distance, and we can go 300 feet here. And this will show you what is causing you, or your foot distance and what is causing you the PIM. So we'll go measurements again. Our red dot is selected for distance to PIM. Go test on, and it runs for however long you have your PIM versus time set up. So I think I have 30 seconds set up right now. So I'll run it for 30 seconds and it'll show your little bar graph down here. And so right now it's showing my spike right here is at 12.36 feet. So it's saying that there's PIM is being caused by something here. It doesn't tell you exactly what. No, it's a little long for what our jumper is. But very, very low PIM signature. If we had a failing PIM, like a neg 115 or neg 123 DVC, we would see our distance to PIM spike all the way up here at the top. And we can loosen to show you that. Go PIM versus time, change our test duration, do 60 seconds. And again, like the sweep gear, it'll show you loose connectors, bad connectors, bad components. And right now, I'll show you what a kind of a loose connector looks like. We're running at neg 180, neg 170, and what I'll do, loosen up our connector here. I won't take it completely off so I don't have to worry about getting shocked, but I'll loosen that up. And as you see, just by doing that, right when I loosen that connector up, we went up to a failing PIM. So now that we know we have a failing PIM, we want to figure out where that's at. Go ahead and turn it off. Go measurements, distance to PIM. Run our measurement. And that's a little bit better distance. So it's saying our PIM issue is at 8.73 feet. So if this were on the tower, then we would put PIM load on the jumper connected to at the antenna and rule out the antenna. If it's still failing, we just work our way back further and further till we get a good test, or we figure out it was a bad connector, things like that. One of the easiest things to do is go PIM versus time, and I usually set it for 60 seconds or 2 minutes. And again, we'll change that. We'll go test duration. Test duration. Change it to 120 seconds. It's 2 minutes. Back to measurements. Test on. We have our failing PIM there, neg 114, and just by tapping on it there, we see our PIM is bouncing all over the place, and that would be a cause right there. It's just a loose connector. So that's some of the basic troubleshooting, basic setup of the PIM gear. As you see, it goes back down there. Very, very basic stuff for troubleshooting. Best thing to do is just rule out stuff. Get your distance to PIM, figure out if it's on the ground, on the tower. If it's on the ground, start tapping on connectors. See if you have PIMs move around like this. Tap on a connector, it moves, take off the weatherproofing, blow it out, torque it, see if it fixes it. If not, tap on it again, still doing the same thing. Go ahead and take apart the connector or replace it if it's a GMA or GMA press-on connector. So if I want to save this as a test and go, I can turn this off. You can turn it off anytime. I just won't go the full 120 seconds. Go over here, shift file, save measurement, and I'll double check again. We're in internal memory training folder 2. I'll go quick name matrix, and again, to change any of these, we can hold down the key. It'll pull it up, and we can put in whatever we want to. Select enter. Now we created that hotkey, or that quick name matrix key there, so we can just press that and that'll just auto fill in there without having to go and type in the whole thing. So select enter, and it'll say successfully saved. And as far as transferring saved PIMs over to a flash drive, same thing as this Android 2 sweep gear. Over here on our side we have our ports, our power port, Ethernet, some of them have GPS. Let's plug our USB drive into here, start flashing, and we'll go copy, and pulls it up, and we'll go down to training 2, select that folder, click on the bottom here, and again you can either hit enter and collapse all those, or you can scroll down all the way to the bottom, select the USB, over here select copy, say copying files, and done copying. Escape. Same thing goes for deleting. Shift file, go down here to delete. You can go into a specific folder, so this alt site, you can select that, go in here, select a specific PIM that you want to delete, or you can select a whole folder and delete that. So that's some of just the basic setup and basic troubleshooting for the PIM gear. Again, the biggest thing with this stuff is just make sure we have the difference between the PIM load and the sweep load. Make sure we're always clear about what's on the end of the line. Like I said, you can fry it. Whenever we have the PIM gear on, we always want to make sure we have it either hooked up to a full system with the antenna at the end of the line for testing, or with a PIM load on. With the PIM load off, again, you can end up burning yourself or burning someone else. So those are just some of the basics of the Android 2 PIM gear. And this all carries over to whatever frequency it is. This one is 1900. There's 850. There's also 700. So it all kind of carries over with the same Android 2 style PIM gear.